Hello everyone and welcome back to the Nerd Cave. In this video I'm going to show you how to make this DIY MIDI controller based on a Raspberry Pi Pico. Now you don't have to keep this as a MIDI controller, you can also use it as a macro pad, which I'm probably going to do, but I'm going to show you both ways and how to set it up in FL Studio or as a macro pad. But let's have a quick demo to see how does it sound. So I am currently on day 45 of this lockdown, which makes it quite difficult to order anything because you don't have access to deliveries and you are not allowed to leave your compound. But this is not going to stop me with this project since I have access to all these breadboards, and I'm going to use this blue diode laser to make Enclosure. For the final version I plan to make it both compatible with the Raspberry Pi Pico as well as the Arduino, and it have a lot more features. So if you want to see the final version of this MIDI controller, be sure to subscribe to the Nerd Cave so that you won't miss it once this lockdown is over. For the Enclosure, I decided to make it very basic and downloaded Fusion 360 hobbyist version. I always use SolidWorks for most projects, but I decided I wanted to give Fusion 360 a try. Click on New Sketch and then select the top plane. Now select the square tool and choose the center feature. Draw any size of rectangle. We can now go and resize it with the sketch dimension. Make it 220 by 220 millimeters. We can make a hole for our arcade button, and this should be a diameter of 30 millimeters. And we will again use the distance, making it 42.5 from the side and bottom. Now we can duplicate the holes, click on create and select rectangular patterns. Make sure that the distance type is spacing and that the quantity is 4, and we will use a distance of 45 millimeters. To get rid of the sharp edges, we will use a fillet tool and make it 30 millimeters to give us the nice round edges. The only thing that is left is to add the hole for our spacers, which I added a 3mm hole and a distance of 30mm from the center of the outer corner circle. Now you can either do it 3 more times or you can use the mirror tool to mirror it in both directions. I then extruded it 3mm if anyone would like to 3D print this file. I copied the sketch for the bottom part of the enclosure and deleted all the circles. All the files will be available in the description. I went and cut the parts which the laser cutter moved around a little bit due to vibrations of me not securing it so well. So to fix my mistakes, I spray painted it black with just 2 coats to show the wood pattern still. This came out looking very great, and all that was left to do was to secure all the arcade buttons. The Raspberry Pi Pico provides us with a lot of GPIO pins. Since we know that we will be only using 16 buttons, I decided to use 16 GPIO pins to avoid making a matrix for now, since we will need to add diodes to prevent ghosting of keys, which we will discuss in detail once we take a look at the final version, which does use a matrix for the input. I decided to trigger the pins when they receive a high input, or in our case a 3.3 volt, so we will make our pins to be pulled down to ground to keep the logic level low, and we will do this by using the internal resistors by setting it up as a pull down in CircuitPython. To connect the 3.3 volt pins, I used this 20 gauge wire and stripped the insulation to be able to push it through each button to ensure that one side is connected to the 3.3 volt. I used some solder to ensure that the connection was made properly. For the other remaining pin, I used the male to female jumpers, where I cut off the plug end of the wire, removed some of the insulation to connect it to the switch, and soldered it in place. I did this for all 16 keys. I also did a final continuity test with the multimeter to see if each button is conducting when pressed and that there is no short between the buttons. The final part is to connect all the buttons to the Pico. I chose the top right corner to be button 1, but you can start anywhere. This is the basic schematic diagram for all the connections you need to make. After making all the connections, I use some press stick to keep it in place for now, but if you're not going to tinker further with this, you might consider some glue. Once we are done with all the connectors to the Pico, the final step left is to insert the spacers and to tighten the enclosure with screws and bolts. Now we can go look at the programming together. For this part of the video, you are going to need to have CircuitPython installed on your Pico. So if you have never worked with the Pico before, just pause the video here and go watch this video first, where I explain how to get started with the Raspberry Pi Pico using MicroPython and CircuitPython. After you have finished watching that video, come back to this one. And for this project here, all the code will be included in a GitHub repository, so you can copy all that code and you can follow along with this next part. Using the link in the description, it will take you to this page here. Click on code and click on download zip. After downloading, you can open a file and extract the folder named MIDI and MacroPad project to your computer. Now inside Phony, click on view and files and navigate to the directory where you have unzipped the files. Select all the files and right click and select upload to with the / and this will upload it to your Raspberry Pi Pico. If your Pico is not showing here, press the stop button in case it was running another program. Now we have two options here that we can either use this as a macro keyboard or as a MIDI controller. If you want to have your Pico by default running one of these programs, you need to resave it to the Pico with the file name code.py. Let's take a look at the MIDI code first. The majority of this code comes from the Adafruit MIDI Fighter project, where I have used all the basics and made slight changes to make it work for this project. In this first block of code, we import all the necessary libraries that we will need. Here we set up the MIDI to act as a USB MIDI output device. MIDI out sends note from the device. The pins used for the arcade buttons are stored in node pins array. In this for loop, they are set up to be digital inputs, and we will make the pin mode to be pulled down, so when the button receives a high logic level, it will trigger. We will append all these inputs to the list node buttons. Each arcade button has a stage setup for debouncing. The MIDI nodes array hold all the default MIDI nodes that are assigned to the arcade buttons. If you want to change the MIDI nodes, you need to edit this array to the MIDI node that you want to use. Now we create an endless loop to loop through our 16 buttons to see if any button is pressed. If a button is pressed, it will assign MIDI node number out with a MIDI node on message. Now run this code and we will go to FL Studio to set up our MIDI as a drum pad or anything else that you want. But we will focus on a drum pad for this video. Click on options and go to MIDI settings. You will see the CircuitPython as an input, but also as an output. Make sure your MIDI settings is set up as indicated here. Now to set up your MIDI as a drum pad, click on this downward arrow here and go to map nodes for entire bank. Then you'll start from here and go all the way upwards. After doing that, you'll see this is now mapped with your FPC. Now there's a lot of other things you can do. I have not worked with FL Studio before, but for example, when you do press a note, you'll see the note being sent, your MIDI note. So for example, there are so many different things to choose from in FL Studio, so if you are a music producer or you're just getting started, this DIY MIDI controller will help you a lot. Now in this section, let's quickly look on how to set this up as a macro keyboard. So first go press stop here, and then we'll go to the macro keyboard.py and we'll click run script. Now again, this is all the keys here that is mapped. We import all the necessary libraries. And here we set up the consumer control, the keyboard device, and also for the keyboard to write strings. I also have explained all this in a previous video, so if you go check on my channel, there is a DIY macro keyboard. Here again we set up all the buttons and we'll set up as a pull down. Now here you can go and change all the code to do different things. Now since this is running from key 0, 1, 2, 3, 4, 5 all the way up to 16, it will print out the number. So just to show you my console, 0, 1, 2, 3, and this one should be 15. I hope you found this video useful. I am planning to do more projects during this lockdown time, so if you want to support the channel, press that subscribe button and also press like, and I will see you in the next video.